Okay, these are the mole notes. And no, I'm not talking about the little creatures that burrow or that actually live underground in your backyard. No, we're talking about chemistry moles. Little different here. Okay, a mole in chemistry is actually a counting number. It is used to count the number of particles, atoms, molecules, ions, etc. Kind of like, well, if you're talking about eggs, you're talking about 12 eggs. You're counting 12 eggs. You've got a dozen eggs. A baker's dozen is 13. A bushel, I think, is 244. Okay, all of these are counting numbers. Okay, they're counting units. And that's what a mole is. Okay, so actually, let's go ahead and erase the word number, because it's more of a counting unit. You use it as a unit. Like, we know a dozen is 12. Okay, we know that a baker's dozen is 13. Well, we have something called Avogadro's number. Now, Avogadro's number is the amount of particles in a mole. And that number is 6.02 times 10 to the 23rd. That's a number you will have to know. Upwards, backwards, forwards, whatever. You will have to know that number because you're going to be using that number this entire unit. Okay, so now if we are going to convert from moles to particles, we have to multiply. Whoops. Pen wasn't working. We need to multiply by 6.02 times 10 to the 23rd. So all that scientific notation stuff we did, and remember how we used the scientific notation when we were doing light problems, and you guys really didn't want to use it anymore? Well, guess what? We got to use it again. Okay, we're also going to be using picket fences again. I know everybody just loved those picket fences. So we're going to convert how many atoms are in 2.30 moles of iron. So this right here is what you're given. Okay? So we're going to start out with our picket fence. And if you remember in the picket fence, we always put what we're given in the first block. Okay? Now, we have a conversion factor. That conversion factor is 1 mole equals 6.02 times 10 to the 23rd. And in this case, we're looking at atoms. Okay, which means one part has to go on top and one part has to go on bottom. And if you remember, in order to get rid of a unit, you have to put that unit on bottom. Right now we have moles of Fe. So in order to get rid of the mole unit, we have to put the 1 mole of Fe on bottom. Okay, that means on top we put 6.02 times 10 to the 23rd atoms of Fe. Okay, this way we can cross off moles and all we're left are atoms. Now, when you're using your graphing calculator, you can actually do this in one step. Okay, all you do is you put in parentheses 2.30 and then put in parentheses 6.02 times 10 to the 23rd. When you do that, you get the right answer. And you should be in scientific notation altogether. Now, if you'll notice here, our number, 2.30, has 3 sig figs. Okay, that's how many sig figs our answer is going to have. And what I'm going to try and do is keep it at 3 sig figs so that you know your answer should go, you round to the nearest 3 sig figs. So in this case, it's 1.38. I think the original number was like 1.384, blah, 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 a whole bunch of numbers. Just round to 3, your first 3 numbers, 1.38 times 10 to the 24 atoms of Fe. That's your answer. Okay. Now, when we want to go the opposite way, if we want to convert from particles to moles, we need to divide. Okay, we're dividing, not, whoops, I keep forgetting to put my pen on. We're dividing by 6.02 times 10 to the 23rd. Now, I'm going to put the conversion factor up here again. Times 10 to the 23rd. In this case, we're looking at molecules. And, of course, we've got to have our picket fence. So, I'm going to put a line through here. I'm not going to put the bottom. Oops, this should be an example. I'm not going to put the picket part yet until I've written my number. So 5.86 times 10 to the 21 Now, I abbreviate molecules like that, because moles is MOL, but molecules is that. Then we're going to put 6.02 times 10 to the 23rd molecules of H2O, and then 1 mole of H2O. Oh good, we can erase some of this line. Okay? Now, when we put it into the graphing calculator, we've got to put it in a little differently. This is a division problem. You have this one number on top and one number on bottom. So what you really have is this. Now, if you put both of these in parentheses, so it's parentheses, the 5.86 times 10 to the 21st, hit the divide by sign on your calculator, and then put the parentheses again, and put 6.02 times 10 to the 23rd in those parentheses, you will get the right number in the correct number of scientific notation, I think, on some calculators. Some calculators may give you the number in regular notation, which would be 0.00973 moles of H2O. Either number is correct. You don't have to keep it in scientific notation, only when your answer is the particles, whether it be atoms, molecules, whatever, because that's going to be a great big huge number. But the number of moles, you can either keep it in scientific notation or put it in regular notation. Either way, because this right here is 3 sig figs, just make sure your answer is in 3 sig figs. And as I said, I'm going to try and keep 3 sig figs. Okay, this is actually what we call 1/2 of the mole bridge. There's a big old mole bridge, so I'm only going to show you half of it right now. When we get to the end of this unit, you will need to know the whole entire mole bridge. In other words, you'll probably end up putting that on your index card, because once again, you'll get an index card. So, we put our mole here, and we put our particles here. Remember, particles, atoms, ions, molecules, and any other kind of particle you can think of. Now, when we're going from moles to particles, we're going to multiply by 6.02 times 10 to the 23rd. When we're going from particles to moles, we're going to divide by 6.02 times 10 to the 23rd. Now, remember, if it's multiply, it goes on top. So the multiply equals on top, and divide equals on bottom for the mole bridge, or for the picket fence. Oops, I can't write today. Okay, so if you keep this in mind, this is probably the most, for this particular concept, you need to know this diagram right here, this half of the diagram. So definitely when you write this down, make sure you don't lose this, because when we do the warm-ups tomorrow, or Monday, because it is Friday, when we do the warm-ups on Monday, then you will need to use this. Okay? Well, I guess I see you guys on Monday. Good night. Bye.